When you see a beautiful image, would you not like to shoot it with a camera? Gone are the days where we relied on traditional camera, where we used silver based photographic films. Nowadays, digital cameras are very prominent. Do you know why? Because of the immense advantages that it has given us. Now, how is that possible? It's all because of a simple device. Welcome to another session. The topic of discussion would be on that very useful device, which is called as charged couple device, which we shortly call it as CCD. Let us dive into this topic. Come. Okay, we will understand the concepts of our topic CCD by answering three questions in our presentation. The first question we will ask ourselves is what a CCD is and what is it made up of. The second question that we will ask is how a CCD is operated or how a CCD is made to work. The third question, where CCD is used, under which we will list down a few real-time applications of CCD. We will get to find out the answer for the first section. First question, what is a CCD? CCD is nothing but charged couple device, which comes under the category of charge transfer devices. These charge transfer devices are semiconductor structures where discrete charge packets are transferred. There are two main methods of constructing these charge transfer devices. The first method is charge couple devices, shortly called as CCD. The second method is bucket brigade device, shortly called as BBD. Okay, what is a CCD? A CCD is nothing but a shift register formed by a string of closely spaced MOS capacitors, metal oxide semiconductor capacitors that have the ability to store and transfer analog signals, which can be either electrons or holes. And these electrons or holes can be introduced either electrically or optically. From the figure, you could notice that a CCD is going to be made up of a series of MOS capacitors. We will take one pixel of it, one component of the series of MOS capacitors, one MOS capacitor will take and we will try to analyze its structure. We will try to understand the structure of a CCD. The screen shows a single MOS CCD structure. It has a P-type semiconductor body, we call it as the substrate, a thin silicon dioxide insulating layer and a gating electrode. The metallized electrode is connected to a signal voltage, and the CCD structure also consists of a large number of light sensing elements on a thin silicon substrate. We will try to understand the concepts of CCD by taking a small example. The objective is to capture an image using a digital camera. We will try to find out how an image is made. This image is made inside a camera with the help of a CCD chip that is going to be present in it. You could notice from the screen there is a CCD chip inside the camera which helps us to record images in it. So what a CCD chip is? It's an IC which is formed by an array of linked or coupled capacitors. So what's the principle? When light is made to fall on a pixel, it is converted into a charge pulse. The charge is captured in a pixel, a storage place. So when more light is made to fall on the pixel, more charges are accumulated in the pixel. So this is a representation of a small part of a light sensitive surface of the CCD chip, where, as said earlier, it is nothing but an array of pixels. You could notice that the value in every pixel gives the charge which is related to the light intensity. So light is made to fall on the pixel, and based on the intensity of light, the charge is accumulated in the pixel. You could notice it from the table given here, from the CCD array given here. You do have variations in the charges that have got accumulated in each and every pixel. So there are three phases associated with recording an image or capturing an image using a digital camera. Phase number 1 is clearing phase. The second phase is called as the integration phase. And the third phase is called as the readout phase. By understanding each and every step, we will try to understand the whole concept of CCD. The first phase that we will take is integration phase. We will take up the clearing phase at the last. Integration phase is otherwise called as exposure phase, right? Where or when during this phase the image of the object is projected on the CCD chip. We have taken a single MOS capacitor device. Okay, as you already know, a CCD chip consists of an array of pixels. Each and every pixel is going to be made up of a single MOS capacitor. The functionality or the basic work of a MOS capacitor is to store charges. Right? When does it store? When light is made to fall on the MOS capacitor, it generates photoelectrons and stores it, right? So this is the concept that we will understand. We will keep in mind. We will try now. So in the integration phase, what we really do is we expose the CCD device to light. And what really happens? So this is going to be the structure. We will just have a small recap of the structure. So this is the P-type silicon substrate. This is your photosensitive element, an array of light sensitive element. So this is going to be your silicon dioxide layer, and this is going to be your gate, polysilicon gate, and you are going to give reverse bias to this gate. Fine? Right. So we will try to understand what really happens when light falls on it. When light falls on it, right? So the light sensitive elements will absorb the energy imparted by this light, and it will generate electron hole pairs. And these holes, now what we'll do is we'll get attracted towards this reverse bias that we give, and in turn what happens is that you do have a potential well, a depletion layer getting created, and the electrons that are created out of this light, we call it as photo-generated electrons or photoelectrons. Those electrons are going to be stored in the potential well that is being created out of this reverse bias. So this is what is going to happen when light falls on the CCD structure. So the main purpose of this voltage is to create a storage space. One. The second functionality is to transfer the charges that have been stored in the potential well. So that is the functionality of the reverse bias voltage that we give to the gate electrode. So this is all about the integration phase, where we store the charges out of this light. The charges that are going to be generated out of this light. நம்மளுக்கு இப்போ என்ன ஆயிடுச்சு அப்படின்னா லைட் இன்டென்சிட்டிக்கு ஏற்ற மாதிரி இப்போ சார்ஜ் வந்து அக்யூமுலேட் ஆயிடுச்சு ஒவ்வொரு பிக்சல்லையும். இப்போ வந்து இதை வந்து நம்ம ரீட் பண்ணணும். ஸோ டியூரிங் த ரீட் அவுட் ஃபேஸ் தி அப்ஜெக்டிவ் இஸ் டு கெட் தி இமேஜ் இன் யுவர் கம்ப்யூட்டர். அண்ட் ஹவு டு வி கெட் இட்? We get it by reading the amount of charges of every pixel. சரிங்களா? ரைட். இப்போ பாருங்க இதுல வந்து இந்த டயக்ராம்ல பாத்தீங்கன்னா ஒரு மேல சார்ஜ் வந்து அக்யூமுலேட் ஆயிருக்கு. இதே மாதிரி எல்லா பிக்சல்ஸ்லயும் you will have charges getting accumulated. இப்போ நம்ம என்ன பண்ணணும் அப்படின்னா முன்னாடியே சொன்ன மாதிரி தான் CCD வந்து it is a shift register. Shift register என்ன பண்ணும் அப்படின்னா it will shift the contents. When clock pulses are given to a shift register, the contents of the shift register gets shifted, right? இப்போ நம்ம என்ன பண்றோம் அப்படின்னா the charge மேல இருக்கு, it is at the top, right? So we need to get the value or rather measure the amount of charges that is stored in that particular pixel. So what we need to do is we need to shift the content, right? Shift வந்து இந்த shift rows கொடுத்திருக்கு, அந்த shift பண்ணிட்டு கீழ வந்ததுக்கு அப்புறம் என்ன பண்ணனும் அப்படின்னா you need to shift it horizontally so that அந்த வேல்யூஸ் அதுக்கப்புறம் நம்ம என்ன பண்ணலாம் டிஜிட்டைஸ் பண்ணி அதை வந்து நம்ம டிஸ்பிளேக்கு கொண்டு போகலாம். இந்த readout phase வந்து ஒரு அனிமேஷன் வீடியோ மூலமா we will try to understand. இப்போ இந்த ஸ்க்ரீன்ல பார்க்குற buckets வந்து they resemble the pixels in the CCD chip, right? And the rainwater that is collected, right, in the bucket resembles or it correlates with the amount of charge that has been stored inside the pixel, right? The number of electrons that have been generated due to the incident light, photo generated electrons. இப்போ இது எப்படி transfer ஆகுது பாருங்க. So this is how we will transfer the stored charges from one pixel to another, right? So that finally the image is read by the computer. இதையே நம்ம அந்த இமேஜ் மூலமா கொஞ்சம் correlate பண்ணி பார்ப்போம். அதுக்கு ஒரு அனிமேஷன் வீடியோ பார்த்தா இன்னும் நல்லா புரியும். Just have a look at it. The next phase is the readout phase. As the name implies, we are going to read out the charges, read out the values, the amount of charges that have been stored inside the potential well. So in integration phase, we have stored the charges. Now our objective is to transfer the charges so that the electronic circuits are able to retrieve the message with the help of computers. So this is a series, as said earlier, a CCD chip is going to be a series of MOS capacitors, or a CCD device is a series of MOS capacitors. We do have 3 MOS capacitors in series, and we will have the naming of gates as gate 1, gate 2 and gate 3. The objective here is to transfer, say for example, if light has fallen on this gate, right? We would have got a potential well, and inside the well we would have got the electrons being generated, photoelectrons stored in the potential well. Now we need to transfer the charges from one pixel to another. So what we do is, say for example, we assume that the voltage given here is plus 5 volts, and we have had a potential well like this. Okay, so we need to transfer this electrons here. So what is done is, so this method is what we call it as 3-phase clocked pulsing system, right? In the first phase I have given the voltage to be 5 volts. In the second phase, now what I do is, or rather what we do is, we give a voltage to this electrode, and the voltage, the magnitude of the voltage is greater than the voltage that we have given it to gate 1, right? Which means that I assume that I have given a voltage to be 10 volts. Now what happens? We do create a well which is deeper than this well. So what happens? You do have a well that is going to be deeper than this well, right? So this is the objective. So now can you just guess what would be the amount of voltage that I would give to gate 3? Good. So the voltage would be greater than the previous voltages. Might be plus 15 volts or 20 volts or whatever be. Our objective is to get a deeper potential well than the previous wells, right? Okay, the objective, the reason behind is that, so you do create a potential gradient, right? And as a result, now what happens is that, the electrons from this well diffuses to the next well, right? As a result of this voltage, right? So the main condition is that you are supposed to create an overlapping of wells, and only then you will be able to transfer the electrons from one well to the other, right? So this is the condition that we will try to adopt, right? Say for example, if you have given 15 volts, you would have got a much deeper potential well, right? And as a result, now what would happen is the electrons that would have once you give 10 volts, right? So you now the electrons would have come here, and once you have 15 volts, you have you don't have now the potential gradient exists, and so the higher concentration, the electrons try to move from higher concentration towards the lower concentration, and as a result, the electrons move from here to here, right? And this is how there is going to be transfer of charges from one pixel to another. So this is how you read out the charges, the amount of charges that have been stored inside the potential well. This is all about readout phase. We'll move on to the last phase, which is called as the clearing phase. As the name suggests, we are going to clear out all the previously stored pixel values from the CCD chip. இது எதுக்காக அப்படின்னா ஒரு fresh image நான் எடுக்க போறேன் அப்படின்னா பழைய valuesல எடுக்க கூடாது. So I need to remove all the previously stored values when a fresh image needs to be taken. So அப்ப என்ன பண்றோம் அப்படின்னா all charges in a line, ஒவ்வொரு லைன்ல இருக்கிற charges எல்லாத்தையும் will move to the line below it. கீழே வரும். மேல இருக்கிற charges எல்லாம் கீழே வரும். அப்ப மொத்தமா ஒண்ணுனா அப்படி கீழே வந்து என்ன ஆகும் அப்படின்னா we will try to clear it out, right? So this is going to happen with all lines of the chip on the same moment. At the same moment, ஒரே நேரத்துல என்ன ஆகும் அப்படின்னா எல்லா லைன்ஸும் என்ன ஆகும் அப்படின்னா they get cleared out, right? As you could notice from the diagram itself, you do have a clearing line over there. Fine. So these are the three different phases that are going to be there in a when a image needs to be captured using a digital camera. So CCD ஓட summary அப்படின்னு பாத்தீங்க அப்படின்னா முதல்ல என்ன பண்றோம், we will try to aim the camera at the subject and adjust the zoom to get a closer or farther away view. Then we will set the aperture and shutter speed for optimal exposure, right? ரெண்டு மூணாவது பாத்தீங்க அப்படின்னா you will reset the CCD, right? Now this is what is called as a clearing phase because we need to take a fresh image, then expose it to light, right? The object, you expose it to the object. So this is what is called as the integration phase, exposure phase அப்படி நம்ம சொல்றோம். அதுக்கு அப்புறம் என்ன ஆகுது அப்படின்னா so the analog to digital converter, because that is going to be in analog nature, right? The analog, the stored charged photo generated electrons, right? They are converted based on the amount, it is converted into a digital value, right? And ADC does that. Now this is what is called as the readout phase, and you will have processor inside which will interpolate the data that you have acquired, and the output is going to be seen on the LCD screen. பாத்தீங்கன்னா தெரியும் அப்படியே ஸ்கிரீன் உடனே போட்டோ எடுத்த உடனே முன்னெல்லாம் வந்து we do have a film, right? அதெல்லாம் நம்ம டெவலப் பண்ணணும். இப்போலாம் அப்படி கிடையாது. Once a photo is taken, you can directly view it in the LCD screen of the camera, right? So this is all possible because of that CCD device or rather charge couple device. On to the third question, right? Now where we will try to list down the applications of CCD. Now the first application is going to be used in digital cameras. You use it in optical scanners, you use it in video cameras, now all cameras, right? And you could use it in astrophotography, infrared photography and night vision devices. So these are the places where you use CCDs. We will try to list down the advantages that make it worthy enough. The first and foremost thing is that you can instantly view the pictures, as said earlier, where you need not wait for the film to be developed. ரெண்டாவது பாத்தீங்க அப்படின்னா போட்டோகிராஃபர் எடுத்ததுக்கு அப்புறம் ஒழுங்கா எடுக்கல அப்படின்னா he can immediately correct the problem and take another picture. The photographer can take it, right? He has the facility, right? He can erase it and take a new picture. And he can take many shots of the same scene with different settings. That can also be possible. The fourth advantage is that you have the ability, or rather the camera will have the ability to capture and store hundreds of photographs, right, on the same media device. This is another advantage that it has when you go for CCD, right? And you can immediately review the image, and if you do not want it, you can remove it. So these are the few advantages which CCD cameras having CCD chip gives you. Before drawing the curtains, we'll just have a small recap of what we have discussed so far. We have been discussing about charge coupled device, which comes under the category of charge transfer devices. We had seen its structure. So a charge coupled device is made up of a series of MOS capacitors. After the structure, we went into the three different phases that are involved when you want to capture an image using CCD chip. Right? The first phase is the integration phase. The second is the readout phase, and the third phase is the clearing phase. In integration phase, the objective was to store the charges, right, in a potential well, right. So the jargon, the technical terms that we had used was photo-generated electrons, potential well, then the different parts of your CCD structure like P-type substrate, light-sensitive array of elements, then gate electrode, reverse bias. So these are some technical terms we used during that integration phase. Then we moved into readout phase, where the stored charges need to be transferred, right? So they need to be shifted so that the computer could read and retrieve the image from the information that it has got, right? So this is all about readout phase. Readout phase is to read the values that have been, or rather the charges that have been stored in pixels. And the third phase is the clearing phase. Before a fresh image needs to be taken, we need to clear out all the previously stored pixels, previously stored values. So that phase comes as a step when you need to take a new image, right? So these are the phases. And then we went into real world applications of CCD, where it is used in imaging systems, right? A lot of imaging systems, video imaging, then in digital cameras and so on and so forth, right? Finally, we saw the advantages that your CCD gives us. With this hope and wish that you would have understood the concepts of CCD. If you really like the video, please subscribe, click the bell button and share your likes. Thanks for watching. Meet you again.